Hey folks, welcome back. So in the last video we discussed how we can use Python variables and data types. So in this video we will talk about Python operators. So what is a Python operator? An operator is a symbol in programming which takes two operands to perform an action. So let's say if we want to calculate a sum of two numbers, then we can do 4 plus 5 equals to 9. 4 and 5 are operands, and plus is operator which applied on these operands. So that is um, uh, operators and operation. So let's get started with different types of operators in Python. So in Python, we have arithmetic operators, comparison operators, assignment operators, logical operators, bitwise operators, and membership operators, identity operators. So let's get started with one by one. Let's get started with Python arithmetic operators. So in arithmetic operators, we have addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. So let's look at one by one. So in addition, let's say we have a value a equals to 10 and b equals to 21. And then if we do a plus b, so that does addition. So 10 plus 21 equals to 31. Similarly, 10 minus 21, which is equals to minus 11. And when we do a multiplication, 10 into 21, which is equals to 10. And when we do division, so when we do b by a, which is 21 by 10, which is 2.1. And when we do modulus, so it gives us the remainder. So let's say we are dividing a percentile b, which means like a value is 10, b value is 21. When we do that, so it gives 10. Otherwise, let's say if we have a equals to 5 and b equals to 2, and then when we do modulus operation on that, it gives one value. And similarly for exponentiation, let's say we have 2 power 5, then which is equals to 32. So for that we use 2 stars as a operator. And when we do floor division, it gives quotient value. Let's say we have a 5 divided by 2, and then we get quotient of 2 times 2 equals to 4. So quotient is 2. So we get 2 for the this value. So let's write on VS Code. So let's say a equals to 5 and b equals to 2 to print a plus b and run it Python 3 and playground. So we get 7 because a plus b is the value of a plus b is 7. And then let's do subtraction on it, a minus b. So 5 minus 2, which is equals to 3. Let's run it. We got 3. And let's do multiplication. So when we do 5 into 2, which is equals to 10. So let's run the program again. So we got 10. And let's do the division. When we do division, so we should get a value is 5 divided by 2, which is equals to 0.5. Let's run it. So and then when we do floor division for this, we should get 2 because 2 times 2 equals to 4, and 1 will be the remainder. So we get 2 for this. So that is that. And when we do modulus operator, we get remainder. Let's do modulus. I mean, otherwise, let's say a percentile. When we run it, we should get 1 because 2 times 2 quotient is 2, and 2 times 2 equals to 4. So 5 minus 4 equals to 1, which is 1. And yeah, so that's all arithmetic operators in Python. So let's talk about other operators. That's all about arithmetic operators in Python. Let's talk about comparison operators. Let's go back to browser again. So coming to comparison operators always returns a Boolean value, either true or false. So it compares the two operands, whether they are equal or greater than or equal or less than or equal or less than. So we compare these two. We compare two operands based on the operator, and which gives the Boolean value. So let's look at that. So when we do greater than operation, let's say we have values a equals to 10 and b equals to 20, and then if we do b greater than a, which gives true because b is 20, 20 is greater than 10, which is equals to true. And when we do less than operator, I mean when we do less than operation on b and a, b is less than a, which means false, because 20 is less than 10 is false. So similarly, when we do for greater than or equals to, so when we do a b greater than or equals to a, then b is 20 and a is 10. So 20 is greater than or equals to 10, which is true. And let's say we have b equals to 10 and a equals to 10, then also a 10 equals to 10 is greater than or equals to 10, which is true because 10 is equals to 10. So coming to less than or equals to, when we do b less than or equals to a, here we have b value equals to 20 and a value equals to 10. So when we do 20 is less than or equals to 10, which is false. So let's try these operations in VS Code. Let me go back to VS Code. So here we have a equals to 5 and b equals to 2. So let's try a greater than b. So a is 5 and b is 2. So we should give a value true. So and when we use less than b, and then it should give false because a is 5, which is less than 2, so which is false. So we got false. And when we do less than or equals to, so this should also give false because a is yeah, this actually the syntax is incorrect. So this is less than or equals to. So when we do a is less than or equals to b, and then this should also give false because a value is 5 and b value is 2. When we do 5 less than or equals to 2, which is false, so this should give false. So it gives false. Let's say a and b have the same values, 5 and 5, and then when we do it, like we will get the output as true because 5 is less than or equals to 5, which is true. So when we do 5 is greater than or equals to 5, then also we should get true. And then let's say we have 5 value is 7, and then when we do 7 is greater than or equals to 5, which should also give true. When we change the value of 5 to 9, then it should give false. So we have seen greater than and less than and greater than or equals to and less than or equals to. So when we do greater than or equals to on this, it should give false because 7 is greater than or equals to 9, which is false. So this is about comparison operators in Python. So let's talk about assignment operators in Python. Assignment operator is equals to value. So it assigns a value to the variable. So if we see let's say b equals to 20, then we are assigning value 20 to b. So we have other shorthand forms for the assignment operators. So if we look at the table here, so we have assigned the value a equals to 100, which means like we are assigning the 100 value to a. And similarly in the below we have a plus equals to symbol, so which performs addition and assignment. Let's say b equals to 20, b plus equals to 23, which is equivalent to b equals to b plus 23. So here we are doing assignment operation as well as the addition operation. And similarly, when we have minus equals to, so then we do something like b minus equals to 13, then which is equals to b minus 13. And similarly for star equals, and then which does perform multiplication and assignment. So b star equals to 3, which means b equals to b into 3. And same for division operation as well, like forward slash equals to, when we do that, it performs the division and assignment. So b slash equals to 13, which means b equals to b divided by 13. So similarly for modulus operation as well, modulus equals to, which performs modulus operation and assignment as well. So b percentile or modulus equals to 3, which is equivalent to b equals to b modulus or percentile 3. And similarly we can do for float division as well. So for double forward slash equals to, we use this symbol to perform this. So let's say we have the statement like b double forward slash equals to 13, which means b equals to b double forward slash 13. And which is the quotient operation, we get quotient out of the when we do floor division. So similarly we have for exponential calculation, we use double star equals to. So let's say we are using b double star equals to 3, which means b equals to b double star 3, which is b power 3. So we do all these operations using assignment operator. So these are all shorthands. So let's look at all these in VS Code. Let me go back to VS Code. So when we do, let's say b equals to 10, and let's change this to b. So when we run the program, we get 10 because b equals to 10. And let's do b equals to b plus equals to 10, which means b equals to b plus 10, so which is equals to 20. So when we run the program, we get 20. So similarly, when we do minus operation on it, b minus equals to 10, which means b equals to b minus 10, which is equals to 0. So let's run it. So we get 0. Similarly, when we do a multiplication, this is the operator that we use, star equals to, that is equivalent to a into 10, so which is 100. 10 into 10 equals to 100. So similarly, when we go for a division operation, so 10 by 10, which is equals to b, which is equal b equals to b by 10. So the value is and similarly when we do floor division, so we should get the quotient. So b equals to b floor division 10, which means I think we should get 1. So we get 1. And when we do exponential, so which is equivalent to b into b exponential 10, so which means 10 power 10, we get more zeros after 1. So this is the value for that. And similarly we can do modulus operation. So when we do this, we should get the remainder, and which is assigned to b again, so which is 10. Logical operators allows us to take logical decisions like and, or, not. So we in Python we have and or not operators to perform the logical operations. So let's talk about AND. So when we have two operands and we have AND operations, and then both the operand values are true, then only we will get true as output when we use the AND operator. So otherwise we get false. So both the values should be true. When we use OR, either of the values, like either left operand or right operand, values should be true. One of them should be true. Then we get true as a boolean value, otherwise we get false. And not is it inverts the boolean value. Let's say if we do let's say a equals to true, and when we do not a, then that gives us the value false. Then if we have value a equals to false, and when we do not a, and then it gives true value. Let's look at that in VS Code. Let me go back to VS Code. Let's remove all this, and equals to true, equals to false. And when we do a and b, then it gives false, because we have value a and false for value b, a variable b. So we are doing a and b, so true and false, true, sorry, false. So when we have both the values as true, and then we get the value as true. So we can use or. So when we do a or b, then one of the a and b values must be true. So let's run it. So it gives true because both the values are true. Let's say b value is false. Then when we run it also, it gives the true because a is true. A or b, either a or b must be true. So that's how it. When we do true for this and false for this, and then when we do a or b, then we get true because b is true. So if let's say let's apply not operator on b, not b, and then we get false because b value is true. When we are doing not operation, it denotes the value from true to false. So let's do the same thing. Let's apply the same thing on a. Currently a value is false. When we do not a, which converts the false value to true value, true value. So we can see true for the as output. So these this is all about logical operator. Bitwise operators applies on bit level. So when we convert the code to binary level, so it applies on the bits. So these are the bitwise operators. We have bitwise AND operator. So operator copies a bit to the result if it exists in both operands. And for bitwise OR, it copies bit if it exists either of the operands. And bitwise XOR, so it copies the bit if it is set in one operand but not both. And we have bitwise negation operator, which flips the bit if it has value 0, and then it converts the value to 1. If it has value 1, then it converts to value 0. So and we have similarly we have a left shift operand, sorry, right shift operand, so which moves the number of bits by uh, left number of bits specified to the right operand. And similarly we have left shift operand, so the left operand value moved right by the number of bits specified by right operand. So we don't need to know much more about it because it's all related to Boolean algebra. So let's look at simple example for AND operator, how it works. So it works similarly for all these based on bits. So here we have bitwise AND operation. So this is one operand and this is the other, and we are using AND operation at bit level. So when we do 0 and 1, 0 and 1, so both the values are must be 1, then only it considers the value as 1, otherwise it considers that it as 0. So 0 and 1, 0, and 0 and 0 0, 1 and 0 0, 1 and 1 1, and 0 and 0 0, 0 and 0 0. So and similarly for all these zeros. So now we got 0 0 0 1 0 0 0 0, so which is equals to 1 triple 0, which is when we convert this to decimal value, which is 8 to power 3, which is equals to 8. So this is how it works for a binary, sorry, a bitwise AND operation. So similarly, we have a bitwise OR operator and bitwise XOR operator. So we don't need to worry more about these bitwise operators because we won't be using much. So let's talk about membership operators. In Python, we have two membership operators, in and not in. So when we use in operator, so it returns a Boolean value if it finds the given value in the sequence or not. So if the given value is in the sequence, and then it returns true, otherwise it returns false. So for example, let's say we have a equals to 10, and when we are doing a in the iterator or the list or the sequence 1 2 10 20, and then it returns true because 10 is in the given sequence. And for the second one, when we do this a in 1 to 110 and 20, then it returns false because 10 is not in the given sequence. So similarly, when we do for not in, so it works opposite to in operator. So when we do for this a not in 1 to 10 20, and then that returns false because a is exists in this given sequence. And if we do a not in 1 to 110 20, and then that returns true because a was not there in the given sentence. So let's look at a simple code execution for this in VS Code. So let's say equals to 10 and print a in 3 4 and save it. Execute Python background.py. So when it returns false because 10 is not there. Let's add 10 to the sequence and run it. So now it's returning true because 10 exists in the sequence. Let's say b equals to 100, and then b in b not in the sequence. So this is the syntax how we write it. And then when we run it, like it returns true because excuse me, because b not in the sequence because b value is 100. And if we do a not in um, the sequence, and then it returns false because a exists in the sequence. So that's how in and not in operators work. Let's talk about the identity operators. Identity operators talks about memory and memory locations. So when we talk about identity, we use two operators for identity: is and is not. So is returns boolean value true if both variables points to the same memory location in the RAM. um, So is not, it returns a boolean value true if both the given variables are not pointing to the same memory location. So let's look at a simple example. So here we have a equals to 100 and b equals to 100 and c equals to 101, 101. And when we say a is b, it returns true because these two are pointing to the same value. And when we see, when we do like a is c, then it returns false because a and c both are having the two different memory values. So let's look at that here in VS Code as an example. So let's go back to VS Code. Let's define a equals to 100 and b equals to 100 and c equals to 101. And let's save it. Let's run print a is b and a is c. So when we execute it, we got two values. First one is true and second one is false. That's because if the both b and c point to the same memory address, and then that will become true. So how do we confirm that? So in Python, we use inbuilt function called id to get the memory address location of a variable. So let's print the variables memory addresses. A address equals to id of a. Similarly, let's do for b and c. B and c. Let's run it. So if we see here, both a and b, both variable a and b are having the same memory location, and c is having the different memory location. So that's the reason we are getting different boolean values for is and is not. So let's do a is not c, which gives true because both A and C are having the two different memory addresses. So that's all. And when we do A is not B, and then it returns false because A and B both are pointing to the same memory location. Let's see, A is B, and then it returns true because these two are pointing to the same memory. So that's how these identity operators work. That's all about Python operators. So if you find this video is useful, then please do like, share, and subscribe to my channel. Thank you.